Now let us see problem using these two theorem, that is Cauchy integral theorem and Cauchy integral formula or Cauchy fundamental formula. So now let us move on to the question, that is this is the problem. Evaluate integral e to the power minus z by z plus 1 dz where c is the curve modulus of z equal to 2 and modulus of z equal to 1 by 2. So first let us start with the first question. So here first we have to identify the singular point for the first question. First question, the singular point is we have to equate the denominator to 0. So the denominator to the given equation is z plus 1, which is equal to 0, gives you z is equal to minus 1. Right? So here z equal to minus 1 is the singular point. So under this first subdivision we are considering c is the curve modulus of z equal to 2. Now we have to check whether this singular point z equal to minus 1 lies inside this curve modulus, that is inside the curve modulus of z equal to 2 or not. So this is being the singular point. Now let us consider the circle. Let it be the circle with center origin and radius is 2, right? So here this modulus of z equal to 2 means it is a circle with center origin radius 2 and z equal to minus 1. Z equal to minus 1 means this is the point minus 1 and this is the point plus 1. So here z equal to minus 1 is the singular point that lies inside the given curve C. That is C is nothing but modulus of z equal to 2. Since it lies inside the closed curve C, we have to use the second theorem, that is Cauchy fundamental formula. So what is Cauchy fundamental formula? Cauchy fundamental formula is integral over C f of z dz by z minus a. This is equal to a 2 pi I into f of a. So this is the answer. Now what is our question? Our question is here e to the power minus z dz by z plus 1, right? So this is our question. So what should be the answer? It is equal to 2 pi I into f of, what is a here? Just you can compare the denominator here. So z minus a is represented as z plus 1 here. So which means that a takes the value minus 1, or otherwise here already we have identified the singular point as z equal to minus 1. This is nothing but a. So in place of a we can substitute minus 1. Where what is f of z here? F of z is nothing but in this theorem statement, f of z is the numerator term except this z minus a. Similarly here f of z should be e to the power minus z. If f of z is e to the power minus z, we want the value for f of minus 1. So this is equal to e to the power plus 1. So here finally we can conclude that it is equal to 2 pi I into e. So finally this is the value of the integration for the first problem by taking the circle C as modulus of z equal to 2. So next is modulus of z equal to 1 by 2. Now taking the curve C as modulus of z equal to 1 by 2. So modulus of z is equal to 1 by 2 means it is again a circle with center origin and radius is 1 by 2. 1 by 2 means obviously minus 1 will lie outside. So this side it will be plus 1, this will be minus 1. So minus 1 lies outside the circle. So here z equal to minus 1 is the singular point that lies outside the curve C. Okay, so outside the closed curve C. So which means that, what do you mean by this? Then the function f of z is analytic at all points inside the curve C. That is the meaning. So whenever f of z is analytic at all points inside the curve C, why we are telling this is because z is equal to minus 1 is the only singular point we are having. That point also lies outside, which means that the function will be analytic at all points inside because there is no singular point inside the curve C. So here we have to apply Cauchy theorem, right? Cauchy theorem. So using Cauchy theorem, what it states is simply integral f of z dz is equal to 0, which means that here the question is integral over c e to the power minus z dz by z plus 1, right? So in this case altogether it is considered as f of z because here z equal to minus 1 is not the singular point. So all the term together is considered as f of z. So this is equal to 0. So whenever you notice, please notice this, whenever if you have the singular point lies outside means we have to use Cauchy theorem. Based on this the answer is directly you can put 0, right? Here if you notice modulus of z equal to 2 where the singular point lies inside the curve C. Whenever if it is inside the curve C, we have to apply Cauchy fundamental formula. So according to Cauchy fundamental formula, like this we have to find out the answer. Now let us see the second question. Evaluate integral over c cos pi z square by z minus 1 into z minus 2 dz. Where here the c curve C is modulus of z equal to 3 using Cauchy fundamental formula. So here first we have to find out the singular point as usual. So as usual we have to equate the denominator to 0. So z equal to 1 and 2 are the singular points. Here we have to check whether these two singular points lies inside the curve C or not. So here what do you mean by the curve modulus of z equal to 3? It is a closed curve or it is a circle with center, origin and radius is 3. Since radius is 3, 1 and 2 both lies inside the closed curve C. Okay, so that here we can say that z equal to 1 and 2 are the singular point, both lies inside the given curve C, right? Inside modulus of z equal to 3. So since both lies inside the curve C, we have to use what? Cauchy fundamental formula. That is a second theorem. So what it states here, integral over C f of z dz by z minus a is equal to 2 pi I into f of a. So if you check the theorem, here the denominator we are having only one factor, but in the question we are having product of two factors. So here if we have only one factor, directly we can apply this theorem. So what we can do here is, the simplest way is we can split this into partial fraction. So here leave that numerator, just we have to split only the denominator. So let us take 1 divided by z minus 1 into z minus 2. So this we have to split it using partial fractions. So using partial fraction, you can recall the method of partial fraction. So since the denominator is a linear factor, we can consider the numerator as a constant a divided by z minus 1. For second factor, let it be b by z minus 2. So now as usual, we have to find out the value of a and b. Here 1 is equal to a into z minus 2 plus b into z minus 1. So now you know the simplification for this. First you have to put z is equal to 2 so that this a vanish. So b is equal to 1. Similarly, if you put z is equal to 1, then b term will vanish. So a will be equal to minus 1. So b is equal to 1 and a is equal to minus 1. So that 1 divided by z minus 1 into z minus 2 is equal to minus 1 by z minus 1 plus 1 by z minus 2. Now we want to evaluate cos pi z square by z minus 1 into z minus 2. So cos pi z square by z minus 1 into z minus 2 is the question. So we have to multiply by cos pi z square on both sides. So here it will be minus cos pi z square by z minus 1 plus here cos pi z square by z minus 2. Now we have to take integration. So this is what we have to evaluate. So taking integration on both the sides. So minus is here. So minus cos pi z square dz by z minus 1. Again plus this is over the curve C. Cos pi z square dz by z minus 2. So this is equal to, now already we know that by Cauchy fundamental formula, the right hand side value is 2 pi I into f of a. But here a takes the value plus 1 for the first term, and for the second term a takes the value 2. So it should be f of 1 and f of 2. Where what is f of z? F of z is nothing but cos pi z is equal to cos pi z square. So since f of z is equal to cos pi z square, we want the value for f of 1 and f of 2. So f of 1 is what? Before that we have to recall what is cos n pi. What is cos n pi? It is minus 1 whole to the power n, which means that whenever n is odd, answer will be minus 1. Whenever n is even, answer will be plus 1. So for f of 1, z square means 1 square here. Z should be substituted as 1. So 1 square means it will be cos pi. Cos pi means cos 1 pi. So n should be substituted as 1. So which will give you the answer as minus 1. Similarly, f of 2 means 2 square. 2 square is what? 4. 4 pi. 4 is what? Even number. So the answer is plus 1. So here it is minus 2 pi I into, the value is minus 1 here. For the second term here the value is plus 1. So finally we can conclude that the answer is 4 pi I, that is 2 pi I plus 2 pi I gives you 4 pi I, and this is the value of the given integration.